Now that we have seen how to calculate the limit of a function, let's get back to our starting point, to motivations for the introduction of a concept of limit. It was about being able to find the tangent line to the graph of a function, or about finding the instantaneous speed of a solid that moves along a straight line. So let's look at an example. Let's say we want to find the tangent line to the graph of the function 2x squared plus 3x minus 1 at x equal to. Of course, when we say find the tangent line, we mean find an equation of the tangent line. So to find an equation of the tangent line, we need two things. We need one point on that line and its slope. The point, or point of tangency, has first coordinate 2, and it is a point on the graph of the function. Therefore, its second coordinate is simply the value of the function at x equal 2. And here, if we plug x equal 2 in this function, we get 13. So the point of tangency, which is a point on the line, will have coordinates 2, 13. The slope, as we have seen in the very first video, is going to be given by the limit, as x is approaching 2, of the difference quotient f of x minus f of 2 over x minus 2. Now we know how to calculate these kinds of limits. The limit is of f of x minus f of 2 over x minus 2 can be obtained by simply substituting f of x and f of 2 by their values. So here is f of x, and here is f of 2. Now if we simplify the top, we get 2x squared plus 3x minus 14. Now we know, without even checking that this polynomial is going to be 0 when x is 2, because it is in fact another way to write f of x minus f of 2, which of course is 0 when x is 2. Because it's polynomial, and it is 0 at 2, we know that x minus 2 is a factor in that polynomial. So we factor it. The second factor at the top is 2x plus 7. And now we have a common factor x minus 2 that we can cancel without changing the limit at x equal 2. The resulting function is polynomial, just 2x plus 7, and therefore to evaluate the limit at 2, we just need to plug x equal 2 in it, and we get 11. This is our slope. Now the tangent line that we're looking for is the line through the point of coordinates 2, 13, and of slope 11. Therefore, its equation is y minus 13 equal 11 x minus 2. In other words, y minus second coordinate of the point of tangency equals the slope multiplied by x minus the first coordinate of the point of tangency. Let's look at a different example, something about velocity. Let's say an elephant falls off a 144 feet high building, and after t seconds, we know where he is relative to the ground. Specifically, he is 144 minus 16t squared feet from the ground. And we want to know what is its velocity after 2 seconds. So its velocity after 2 seconds is going to be the limit, as t is approaching 2, of the average velocities on the interval of time between time 2 and time t. In other words, of the difference quotient s of t minus s of 2 over t minus 2. Again, we substitute for s of t and s of 2 their values. Here is s of t, here is s of 2. The at is what we obtain if we plug t equal 2 in the equation for s of t. Again, we can cancel things out, and we get the limit, as t is approaching 2, of 64 minus 16t squared, or that over t minus 2. One more time, we know in advance that this polynomial in t is going to be 0 when t equals 2, because this is just another way to write s of t minus s of 2, and that certainly is 0 when t is 2. That means that we can factor out t minus 2 in this polynomial. In factored form, we obtain negative 16 times t minus 2 times 2 plus t over t minus 2. This way, the common factor t minus 2 appears, and after cancellation, which does not change the limit at 2, we obtain the limit of negative 16 multiplied by 2 plus t. That is polynomial in t, and therefore to get this limit, we only need to plug t equal 2, and we get negative 64. The unit is feet per second, because in all this, we have measured distances in feet and time in seconds. Now in the same situation, we could ask, when does the elephant reach the ground? It reaches the ground if its distance from the ground is 0, in other words, if s of t is 0. If we set s of t equal to 0 and solve for t squared, we get t squared equal to 9. That means t is either plus 3 or minus 3. However, in this situation, t is time and flows positively from an initial time t equals 0. So only the positive solution t equals 3 is relevant. In other words, the elephant reaches the ground after 3 seconds. Then we may ask, with what speed does it strike the ground? Well, this is simply the speed after 3 seconds, and we can calculate that exactly the same way as we did calculate the speed after 2 seconds. It's going to be the limit, as t approaches 3, of s of t minus s of 3 over t minus 3. In other words, we take final position minus initial position over time span for an interval of time that starts at 3 and finishes at time t, and that gives us the average velocity over that interval of time. And then we take the limit as the time span of the interval goes to 0 to get the instantaneous speed at time 3. Substituting for s of t and s of 3 their values, we get 0 for s of 3 because this is how we found the time t equals 3. And we know in advance that we can factor t minus 3 in what we have at the top. There is a factored form. After cancelling the common factor, we obtain a polynomial in t, and to obtain the limit at 3, we only need to plug t equals 3 in this, and we obtain negative 96 feet per second. The fact that we get negative values for these velocities at time 2 or at time 3 is because we are measuring the position positively as a distance from the ground, and since the elephant is falling, it is moving towards the ground, and therefore velocity is negative. In other words, it is moving in the negative direction.